Effect of rollers on friction. So for this, you see students, pull a suitcase without rollers. And pull a suitcase which has rollers. We are pulling a suitcase without rollers, and we are pulling a suitcase which has rollers. In which case pulling is easy. Why? Observe, my dear students. And in the railway stations, whenever you are carrying a luggage, we'll pull that luggage. So, with rollers and without rollers, we are seeing. Next one, pushing a book lying on a table. This is a book, lies on a table, and you push it, and now place 3 or 4 pens or pencils. So 3 pens or pencils. Put a book over 3 or 4 pencils. The same book I am keeping, and push with your hand. And observe in which case it is moving easy. So this is the book kept on the table. You are pushing with a finger. And now place the book over 3 or 4 pens or pencils without caps. Now push it. See in which case it is moving easier. So we observe that it is always easier to roll a body than to slide. It is always easier to roll a body than to slide. From these two small and easy observations, we can conclude that so it is always easier to roll a body than to slide. So these rollers, and here the pencils or the pens are using as a rollers, converting the sliding friction into rolling friction. So that's why it is becoming easy to move, and it is easy to pull or push. So from these two activities we can define the rolling friction also. When a body rolls over the surface of another body, the friction offered is called rolling friction. When a body rolls over the surface of another body, the frictional force offered is called rolling friction, and rolling friction is less than the sliding friction. That's why we are converting the sliding into rolling. So it is always easier to roll a body than to slide over a surface. That's why all the luggages and in the railway stations we will see that they will pull everything, and which have the rollers, the lot of luggage can be pulled easily with the help of the rollers. Understanding the principle of ball bearings. How does ball bearings works in rotating parts of the machines? So ball bearings are used to reduce the friction between rotating shafts of machine tools. we use ball bearings. For this, small activity is given in the textbook. Take two leads and rotate them by putting one lead on the top of the other. Take two lead support plates and put one plate on the top of the other plate like this and try to rotate it. Now take 4 or 5 marbles and put these marbles on the top of the first lead. 1 marble, second marble, third, 4, 5. Now put the second lead on the top of the marbles and rotate them, and observe in which case the rotation is easy. So obviously when marbles are there between these two plates, you can rotate faster and faster. So the marbles are working here like ball bearings, so which are reducing the friction. To reduce friction between rotating shafts. Shafts means long, narrow, cylinder or rod. Long, narrow rod or cylinder. So sometimes the cylinders, one cylinder has to rotate on the other cylinder. When they directly in contact, when they are in contact directly, due to friction they will very easily, and lot of energy is required to rotate them. So in those situations we keep ball bearings, solid iron balls or like our marbles, will keep these ball bearings between them, so that rotation becomes smooth and faster. With less energy we can make them to work. So the task of ball bearings is to reduce the friction between rotating shafts, means to reduce the ball bearings what they will do, my dear students. Ball bearings reduce rotating friction, reduces the rotating friction, that is called rolling friction, between shafts. So this is the task of this is the principle of ball bearings. Now what is fluid friction we are going to see. Take a glass of water and stir it with spoon. Take a glass of water, so this is a glass of water, and stir it with a spoon. We observe that water whirls in the glass of water. Water in this glass whirls around an axis, and you stop stirring and observe what happens to the water. When we stop stirring water, we observe that speed of the water gradually decreases. And after some time, water comes to rest. That will be in stable state. So we are taking a glass of water and stirring with the spoon and stopping and observe what happens to the water in this glass. So we observe that the water starts whirling about an axis. The water is whirling about an axis and its speed gradually decreasing. After some time it comes to rest, means it is in stable state. So why does the water comes to rest? Who is stopping the motion of the water? If you raise a question, what force is responsible for stopping rotation of earth? Means frictional force, that is frictional force between water layers and between water surfaces and glass surface. And glass surfaces are responsible for stopping the rotation of water, because we can observe that when we are whirling, stop water moves with greater speed, and below water with less speed, below water still less speed, and below less speed. Means entire water we can divide into different parts. The entire water we can divide into different layers. So below layer stops the motion of the top layer, and this below layer try to stop its motion. This below layer try to stop its motion. Means there is an opposing force between the water layers. So the frictional force between water layers and between water surfaces and a glass surface. See, the water in contact with the glass surface moves with less speed. It is trying to stop it as it is moving. Means, so who is stopping the rotation of the water in the glass? Means the frictional force between water layers and between water surfaces and glass surfaces. Similarly, water and liquids also offers frictional force when objects move through them. So here friction we observed. In the similar manner, water and liquids offers resistance force or frictional force when objects are moving through them. So we can observe the friction offered by water when we go on a water with a boat. So not only liquids, gases and air also. So not only the water, that is liquids, gases and air also offers friction when objects are in motion through them. So here liquids and gases, here liquids and gases are named as fluids, or named as, what is that, children? Fluids. So liquids and gases are collectively named as fluids. So what is fluid? We came to know that. And how fluid is offering friction when object is moving, we have seen. When we go on a boat on the river, on the sea, we can observe the frictional force offered by the water. So not only liquids, gases and air also offers friction when objects move through them, like the objects like aeroplane and jets, when they are moving, air opposes its motion. So that's why, so here liquids and gases are collectively known as or named as fluids, and the frictional force offered by, so the frictional force offered by the fluids is called drag. So the frictional force offered by the fluids is called fluid friction. For that fluid friction, we are giving a name drag. So that is about fluid friction. Okay, students, now we are going to identify factors influencing fluid friction. Factors influencing the fluid friction. We know, so here for a fluid friction, I am using the shortcut FF, fluid friction. The frictional force exerted by the fluid is called a fluid friction or drag. The frictional force exerted by the fluids is called fluid friction or the drag that we learned in the fluid friction concept. So now, on what factors the fluid friction depends on, we are going to see now. On what factors the fluid friction depends? The fluid friction depends on speed with respect to the fluid. Means in the fluid, with what speed the object is moving, it depends on the speed of the object. So the fluid friction depends on speed of the object with respect to the fluid, and it also depends on shape of the object. So it depends on shape of the object. So the fluid friction depends on shape of the object, depends on nature of the fluid also. So the fluid friction, another name for the fluid friction is fluid friction, means the frictional force exerted by the fluids is called fluid friction, and it is also called, what do you know, children? So that is called drag. It depends on with what speed the object is moving in the fluid. It depends on shape of the object. It depends on nature of the fluid, with what speed it is moving in the fluid. And next, when the object moves through fluid, when an object is moving through a fluid, they have to overcome that fluid friction.
So when the objects are moving in the fluids, they have to overcome the fluid friction. To overcome the fluid frictions, we have to keep some efforts to decrease the fluid friction. So to minimize the fluid friction, objects are given special shapes. So for that purpose, we are giving special shapes to the objects. So, do you find any similarity in the shape of an aeroplane and bird? So, the shape of the aeroplane and the bird are similar. So, and all vehicles are designed to have a particular shape. See, the old what is it, cars and the new cars, and the old trains and the new tyres, old cars and the new cars, old trains and the new trains. You see, there will be a shape in the front. So that is to minimize this. The shape will be reduced like this. So shape is reduced. Why the shape is reduced means to minimize the frictional force. And where do you think the scientists are getting these kind of shapes? Means, of course, that ideas may come from the nature only. So here the author is telling that, so how can we give why do we give that shape only for aeroplane, and why should we give that shape only for a car? Means the scientist may get an idea by observing in the nature. So that's why there is a similarity in the shape of an aeroplane and bird, and also all vehicles are designed to have shapes which reduces fluid friction. The frictional force exerted by the fluids is called drag, and that fluid friction depends on three factors. One is the speed. If the speed increases, fluid friction increases. It depends upon the shape of the object. It depends on nature of liquid.